Welcome to the video lecture on parallel lines cut by transversal. The learning targets for you to understand the angle relationship when a parallel line is cut by a transversal. Your three success criteria is to understand how transformations construct angle relationships. You have to be able to identify and name the angle relationship and construct equations based on those angle relationships. So let's look at our core concept of what a straight line is. There's a line and it is cut by another line. And there are two angles that get created, and we know those are linear pairs. And we can do vertical angles. Angle A is congruent to angle A. B is reflected to make its vertical angle of B here. So we know that there are congruent angles. Angle A is congruent to angle A, and angle B is congruent to angle B by vertical angles. We also know that there are linear pairs. That angle A plus angle B is equal to 180 because they make a linear pair, and vice versa. So let's explore this by now extending that red line that we cut through. We extend it a little bit further and have it cut another longer line. Okay, this was our original angles that we had before. Angle A, B, then this is also angle A, and this is also angle B due to vertical angles. And we cut another line that is parallel to that. So we gotta talk about what parallel lines are. Notice that there are these two symbols right here that indicate that they're parallel lines. Okay, parallel lines have lines that are equal distance from each other. Now what I would like you to do is watch the line slides. So that parallel line that we had here is going to slide up right on top of that. You could also think that as a translation. The bottom line translates all the way up to the top line. And the fact that it's right on top of it, it's going to slide back down, bringing those angles with it. Okay, this was angle A, this is angle B, this is angle B, and this is angle A. How they're getting these angles are because they got it from above here, because it was only a translation. If you notice or wonder anything about these angles, you should notice that the lines are parallel, therefore they share identical angles. Why? Because this was only through a translation, and we know translation is a rigid motion transformation, and during a rigid motion transformation the angles are congruent. We can say that the line is just translated down. The angles don't change during the transformation because it is a rigid transformation. So the above line have the angles AB on top and BA. On the bottom, it's going to be the same. Now let's explore those angle relationships. How is angle A and angle B related? We could say that the inside angles have to be linear pair. The reason why they're linear pair, okay, is because notice that these are reflections. So B and B, A and A. So A plus B has to add up to 180 degrees. Now let's just replace these variables with numbers so we could get a better understanding. This can be 1, 2, 3, 4, and the bottom one 5, 6, 7, and 8. Okay, I just color coded here to show you which ones are the same. So now let's look at some angle relationships. How is angle 2 and angle 6 the same? Angle 1 and angle 5, are they the same? 3 and 7, are they the same? And 4 and 8, are they the same? And if you look, right, they're the same color. And remember, they are the same because we slide it up and slide it back down, so the angles were the same. We have a special name for this. We call those corresponding angles because these angles were grabbed from these angles when the line slid up there and slid back down. So we could say that these two angles are corresponding when they have the same corresponding position. Corresponding angles can be written in terms of the equation as using the congruent symbol. So we could say angle 1 and angle 5 are the same, angle 2 and angle 6 are the same, 3 and 7 are the same, and 4 and 8 are the same, and that is because they're corresponding angles. What do you notice about these, right? 5 and 4 and 3 and 6. They're both on the inside. They're the same color. So what does that mean? We would say that the two angles are alternate interior angles when they are on opposite sides and lie inside the parallel line. So if you take a look, first of all, this is in between the parallel line. So we call this interior angles. The alternate just comes from they're across the red line. So 3 and 6 are on alternate sides of each other. 4 and 5 are on alternate sides of each other. That's why it's called alternate, because it's on alternate sides and it's on the inside of the parallel line. So that's why they call it alternate interior angles. And we know based on the colors that they are the same. They're congruent. So we could say that angle 3 and 6 are congruent, and angle 4 and 5 are congruent because they are alternating interior angles. Now let's take a look about these 2 and 7 and 1 and 8. What do you notice about them? Well, they're the same color and they're on opposite sides of that red line. So what do you think those are called? Alternate, because they're on alternate sides of that red line, and they're on the outside of the parallel line. So that's where the word exterior angles come from. And we said when they're on opposite sides and lie outside of the parallel lines, that's what we call them alternate exterior angles. And we know they are the same color, so they are congruent. So angle 1 is congruent to angle 8, and angle 2 is congruent to angle 7. What do you notice now about these two? 3 and 5. Notice they're both on the inside and they're on the same side out of the red line. 4 and 6. Notice they're opposite colors too. So we call these consecutive interior angles because they're on the same side. So 3 and 5 are on the same side. That's why we call it consecutive. And the fact that they're in between the parallel lines, we call them interior. So we said two angles are consecutive interior angles when they're on the same side and lie on the inside of the parallel line. And again, they are opposite colors. So we would say that they add up to 180 degrees. So 3 and 5 adds up to 180 and 4 and 6 add up to 180. It's only consecutive interior angles add up to 180 degrees. This is a typical problem that we use to identify vertical angles, to identify pairs. So angle 4 here is 120 degrees. Why? Because by vertical angles. If this is 120, this also has to be 120. We could do some linear pairs to solve for angle 2, which is the problem here. We said that 120 plus angle 2 has to be 180, and if we do that algebra, angle 2 has to be 60. Since this is 60 degrees, we know that angle 3 also has to be 60 degrees because of vertical angles. Now we can apply the angle measurement properties. We would say that angle 5 is corresponding to 120 degrees because it's in the same corresponding part. We know that angle 6 is corresponding to angle 2, which is 60. Now you could do vertical angles. So 7 and 6 are vertical angles. So that's 60. Or you could say 7 and 3 are corresponding. 8 is vertical angles to angle 5. So this is 120. Or you could say that angle 4 and angle 8 are corresponding angles. So this is just using vertical angles, linear pairs, and corresponding angles to identify all the angles in this image. This is what I would like you to do now for the practice. You're going to find all the missing angle measurements in 4, 5, and 6 using what we just covered. Pause the video and give this your try. In the end, make sure you tell me what the X is in that image. Here's the solution. We would say that this is 134, and again, that is through linear pair, because if 134 plus 46 is equal to 180, so this, right, has to be a linear pair. That's why this is 134. Then we could do vertical angles. By this is 46, because it is reflecting from this 46. If this is 134, that also that has to be 134 because of vertical angles. Now you could do the corresponding part. The X here is 46 because it corresponds to the 46 there. The 34 here corresponds to that 34. Then you could do vertical angles down here. So in the end, X is equal to 46. Number 5. 111 is this angle. 69 is this angle because of linear pair. Let's see, 69 plus 111 is equal to 180 degrees because this makes a linear pair. Now we could do vertical angles. If this is 111, this is also 111. The bottom right hand side is 69 because of vertical angles. Now we can do the corresponding. The top right hand corner is 111 because of up here. So this is 69. This is 111 through with vertical angles. This has to be 69 because it's vertical angles here. So X in this case is 111. 6. Linear pair to get the right hand side here to be 5. Then we do some vertical angles. 175 and 5 here. We do corresponding angles here. This is 175 because it corresponds to the 175 above there. This is angle 5. The bottom right is the bottom left is 5 and the bottom right is 175. X is going to be equal to 175 here. Okay, so that's it. This is how we can tell of the angle measurements using the properties of the angle relationship within a parallel line.